Hello, my name is NOEL'S. I'm a member of the QSMEE, and at the present time I'm building 3 locomotives. The one we're going to talk about today though is the Price AR in 5-inch gauge. It was a New Zealand logging locomotive built by Prices at Thames on the North Island of New Zealand around about 1926. The line itself went along the south coast and ended up at Port Craig. There was no road for most of this distance, so the logs were taken to the mill at Port Craig and then loaded onto ships for transport to the markets. This Price locomotive worked in the very south of New Zealand, one of the last big logging operations that was started in New Zealand in the mid-20s. It was on the south coast, an area that has very bad weather and is quite rough and remote. This book that the map comes from is a book about the logging operations at Port Craig. They didn't go on for a very long time, but they certainly had some of the most modern logging equipment in New Zealand. The loco itself, number 115, was given the works designation of AR. It was a Maya type locomotive with cylinders on both trucks, driving a jack shaft halfway between the 2 axles, and it was then spur geared with a step down ratio of 2:1 to each axle. The boiler fed steam via flexible steam pipes to the trucks, and the exhaust exhausted via these pipes under the boiler and then up the funnel. The locomotive was not terribly successful at first because the exhaust from the rear truck used to come out this exhaust pipe up the top of the cabin, and so was not available to draw up the fire. So it was later modified so that the exhaust from both trucks went up the funnel. Now the frame of the locomotive is a simple ladder frame. It's as close to scale as I can possibly get it. There are a few features which I have changed. One is that the exhaust gases have got to come up through the front pivot for the front truck. So I've got to drill this out and put a new block in. The original was all welded, but in this case this is all angled, made out of angle and bolted together. On this thin gauge material it will be too difficult to do a welded frame. On the frame you can see the drops at either end where the coupling hooks go, because the coupling hooks were quite low on this loco, and by the time the driving trucks are underneath it's going to sit quite high. The brake, this is the steam brake cylinder which works the brakes on both trucks. The handbrake will attach also to this side of the cylinder. On the ladder frame then go the plates. These plates support the tender tank at the back. And coming forwards the side tanks that carry the water for the locomotive. These are simple brass fabrications and are all soldered, and so there will be no leakage. Hopefully there will be no rust, as I've had rust in other locomotives in zinc and eel tanks. Water capacity should be quite good for this locomotive. There are two of these tanks, one either side, and they will all be interconnected with balancing pipes to keep the water levels equal all the way around the locomotive. The space in the centre of the frame then is occupied by the boiler. It will eventually come back to this line here, so a cutout has still to be made in this sheet of brass. And this is the boiler here. It's a coal burning boiler of fairly standard sort of design. With a reasonably large firebox, so it should be able to steam the 4 cylinders of the locomotive. This is a non-superheated locomotive, so the steam pipe and regulator valves come out of this flange on the side of the steam dome here. And the pipes will come out of here, go through the valves, and then down beside the boiler and forwards and backwards through sliding and swivelling joints to both trucks. I'll just say on the back head we have the normal fire door, and there are 2 water gauges to indicate water levels in the boiler. The turret will be mounted here, pressure gauge in front of it here. This boiler has already been tested and has received the boiler number. Its final test will be when it's in steam on the locomotive. This is the forward truck of the 2 trucks for this locomotive. The cylinders are at the rear of the truck, so this is the front of the engine up here. This is the beam that carries the weight of the boiler on top of, under this beam here. And the exhaust from these 2 exhausts here will eventually somehow come up and enter this beam, and then come up the central pivot and then up the funnel. The steam pipes, these are piston valve cylinders, so the steam pipes enter the piston valves here and here, and this will need to have a sliding, a telescopic sliding joint with a ball joint, so that these trucks can swivel in the frame, and they will pivot around this point here. The reversing gear operates by this link coming up and down, up and down, and it will probably be operated by steam pressure in the final locomotive, because it is too hard to get all the linkages in a suitably strong piece of metal to the gear. This truck at the moment is running quite well on air. The cylinders are fabrications, so once this one's working I can then start to construct the other truck. All the pieces are made, but we just have to put them together. The only thing left to do on this one is to put the keyways in the put the keys in the keyways that are already cut in the axles.
I was wondering if you give me any idea of any of the pitfalls there are in building a loco, perhaps assist some of the would-be builders.
One of the problems was that I had sort of partial plans from the builders of the original loco. There are no model plans in existence, and I know of only one other loco that has been built. but there were things that I didn't understand when I started that I now have incorporated into the design. But it does mean a lot of the time you've got to go back and change things that you've already completed. So this has been a long ongoing project.
How long have you spent on it?
I've probably been working on this now for a period of about 10 years. I started with fabricating one set of cylinders and the boiler, and I didn't want to make the second set of cylinders until I'd got the first set running. But now that the first set does run, I proceeded to the second set, which are slightly different to the first set because I've learnt some things in the meantime. Only in this past week have I had the first of the power units running on air, and I will attempt to run it now and show you that it does in fact run.
Thank you, Noel.